Hello everyone, I'm Bassam from Bridge Gap Academy, and in this video we're going to discuss stoichiometry. And we're going to really talk about what is stoichiometry, and the topics we're going to be discussing are what is a mole, um, that's one of the first ones we're going to get into, the molar ratio, and N is equal to M over Mr, where N is the number of moles, and Mr is the relative molecular mass, which you can find in the periodic table. And so, first off, let's start off with what is a mole. So a mole is really a framework we use to measure an amount of substance, especially in chemistry. You frequently use the mole. And so a scientist named Avogadro defined the mole as exactly 6.02 times 10 to the power of 23 particles. And so this is very subjective, and it's quite contextual in that it depends on what exact scenario we're talking about. So let's say we have beaker A, right, and we have beaker B. And beaker A is filled with hydrogen gas. Beaker B is filled with oxygen gas. And so if we wanted to measure how much we have of each, if we try to use, let's say, volume, right, that just wouldn't work. And why wouldn't that work is because the relative molecular mass of hydrogen gas is 2, and the relative molecular mass of oxygen is 32. And so oxygen would occupy a much greater space than hydrogen would. And because of this, they would have different volumes. And so volume couldn't work. The mass couldn't work either because they have different masses. So what we really do use is a mole. And so let's talk about how we find how many molecules are in a mole. And so let's say we're asked how many molecules are in 1 mole of hydrogen gas. And we do know that 1 mole of any element, no matter whether it's hydrogen gas or 1 mole of anything, does not matter what it is, will always have 6.02 times 10 to the power of 23 particles. And so if we're asked for, let's say in this specific scenario, number of atoms, and so now that's quite specific. And why does this matter is because when we're talking about number of atoms, right, it's different from when we're talking about the number of particles. And so when we use Avogadro's constant, 6.02 times 10 to the power of 23, we know that in 1 mole of anything that there are that many molecules. And so 1 mole of hydrogen gas will always have 6.02 times 10 to the power of 23 molecules of hydrogen gas. But if we're asked for atoms of hydrogen right here, like in this question, we're going to have to figure out how many atoms are in each molecule, because we know the amount of molecules, but we don't know the number of atoms. And so what I did over here is I figured out that in each molecule of hydrogen gas, we have 2 atoms of hydrogen, and that's because it's H2, right? So each hydrogen, as I've shown over here, there's 2 hydrogens are bonded to each other to form H2. And so to figure out the number of atoms, all we do is 2 times 6.02 times 10 to the power of 23. So 2 times the number of moles. Sorry, 2 times the number of molecules. And I hope that really helped, because let's say we're asked about ozone. Ozone is O3. And so going into this, if we're asked for ozone, O3, then we would multiply by 3. And why would we do that? Because as you can see over here, ozone has 3 atoms attached to it. 3 covalently bonded oxygen atoms bonded together to form an ozone molecule. And so we would multiply 3 times Avogadro's constant to find out the number of atoms. And that's basically how it's done. Now let's get on to our next topic, and that is the molar ratio. And so the molar ratio is really figured out by balancing equations. And the way I like to really start off with balancing is I make a table such as this, where I divide everything into the left and right, as you can see over here. Everything divided into the left and the right, and the left side represents the reactants and the right side represents the products. And then I like to split everything into the different elements. And so what I really did is I just counted. So we have one carbon here, and I wrote 1 carbon. I have 1 carbon here, and so I wrote 1. I have 4 hydrogen here, and so I wrote 4. I have 2 hydrogen here, so I wrote 2, and on and on and on. And what I need to do why do we call it balancing equations? We have to balance. We have to make these two, left and right, products and reactants equal to each other. And so what I would do is I start off by balancing the hydrogen. So we have 4 hydrogens on our left, and we have 2 on our right. So what I did is I tried to make this 4 and 2 equal to each other by multiplying by 2. And so I multiplied 2H2O by 2. So now I have, over here, I have 4. I have 4 hydrogen on the right. But when in doing that, what I've also done is 2 times the number of oxygen. We had 1 oxygen. So now we have 2. So if we add this up, we have 2 here, and we have 2 here. And so this added together is now 4. Sorry. This added together is now 4. And so there's an imbalance here. This left side is not equal to the right side for oxygen. But for our hydrogen, it's all good. So what we really need to do is focus on the left side now and try to balance that. And how we'll do that is we'll balance this left side over here, which is the 2 oxygen, by 2 as well, so that we can get these equal to each other. And so that's why I added the 2 here. And now everything's balanced if you look at it. If we count, our carbons are balanced. They were always balanced. Our hydrogens are also balanced now. There's 4 on the left, and then there's 4 on the right. So that's good. And then our oxygen as well is now balanced. We have 4 on both sides. And so this is a balanced equation. And from this, what we can do is figure out our molar ratio. Our molar ratio is 1 to 2 to 1 to 2. And so this can really help us start converting things. Now let's work on a different set of equation. And this is for methane reacting with chlorine gas. And so I did the same basic setup that I taught you about. It's the same thing. I split everything into left and right, products, reactants, and I wrote down the different elements. So this time we don't have an oxygen, we have chlorine instead. And so we have one, so the carbons are already balanced, and that's good. But the hydrogens aren't balanced. So let's work on the hydrogens. What I did for the hydrogens is we have 4 on the left, so I tried to equal that with the right. So I tried to get 4 hydrogens on our right. And the only hydrogen containing molecule we have is the HCl. So I multiplied that by 4. But in doing so, now I've also got 4 chlorines. And so 4 chlorines over here, and then 4 over here, that gives us 8. And so we have 8 on our right. So this is balanced, and this is balanced. But our chlorines aren't balanced. So I have 8 on the right. So to balance that, all I did is I multiplied by 4. And so that's where you see the 4 right here. And in doing so, everything has become balanced, and now we know the molar ratio. Molar ratio is 1. Even though we don't write a 1 here, we know that this is a 1 to 4 to 1 to 4. And so that is our molar ratio. And so now let's get into one of our final topics, and that is molar mass. So what really is the molar mass? To find the molar mass, we use this formula right here. It's N is equal to M over Mr. And so the units for N is number of moles, and that's what it represents. M is in mass, and Mr is the relative atomic mass. And over here I have a picture of the periodic table, and that's basically where you can get the relative molecular mass. So remember when we talked about how hydrogen is 1, and so H2 was 2 because there's 2 hydrogens. I also talked about how oxygen is 16 and such. So this is basically where we figure out the relative atomic mass. And so with molar mass questions, there's only like 3 different scenarios that you can be presented with. And let's talk about the 3 different scenarios. So scenario 1, right, is where you'll have number of A. Let's talk about this. This is concerning this theoretical formula where A turns into B. So let's say they ask us, if you have this many number of moles of A, how many number of moles of B will you have? And so this is where the molar ratio comes in handy. Let's say this is a 1 to 1 ratio. We know that if we have 2 moles on the left, we're going to have 2 moles on the right because it's a 1 to 1 ratio. And so that only takes 1 step. For part number 2, scenario number 2, we're going to have 2 steps, and that's because we're converting from grams into number of moles of A, and then that number of moles of A we're converting into number of moles of B using our molar ratio. And let me just kind of, conceptualize and just show that to you on paper. So this is scenario number one, and why I say that this is one step is because all it requires is using the molar ratio to give us moles of B. Why do I call this a two-step reaction, or a two-step kind of solution, is because this is step number one and this is step number two. And so what we're doing is we're turning grams into moles, and then moles into the moles of B using the molar ratio. And how do we turn grams of A into moles of A? Going back, this is the equation. So if we have grams, which is M, we can just multiply by MR, right? N times MR to give us the grams. And so that's how we convert grams into moles. And in scenario number three, let's say we're given grams and we're asked for grams of B. And so this is going to require three different steps. And so each arrow represents one step. And first we're going to have to turn grams of A into moles of A, just like we did in scenario number two over here. And then we're going to turn moles of A into moles of B, just like we did in scenario number two again. But we're also going to have to turn moles of B into grams of B, which is, again, the same thing. We know the relative molecular mass and we know the moles, so we can find the grams. And I'm going to walk you through a solution for a question like this over here. Remember we talked about this equation right here. If I go back into the slides, right here, this is what we got. Remember we balanced this. And so going back into a question, let's say we're asked, we have 4 grams, okay, this is all we're given in the question. We have 4 grams of methane, okay? And the question asks us how many grams of oxygen, how many grams of carbon dioxide, and how many grams of water vapor will there be? And so for that, first let's write down the relative molecular weights of each. So over here, carbon is 12, right? And 12 plus 4 is 16. And so that's why the molecular weight for methane is 16. It's because 12 plus 4 hydrogens and 1 carbon. The MR of all these is equal to 16. For O2, it's 1 oxygen is 16, and 16 times 2 is 32, and that's why that's our molecular weight. Carbon dioxide is 12 plus 32, which is 44. And H2O is 2 plus 16, which is 18. And so what we do is we figure out, we've been given the grams of methane. And so what we do is we convert that into moles. And moles is always going to be our bridge. If you look here, moles is always in the middle. And moles is what really is going to help you solve all these questions, because it's our bridge. It connects between grams. And over here, I use that same thinking. I turned the grams of methane, which is 4 grams, into moles. And so I use the equation N is equal to M over MR, where M is 4, MR is 16, and so 4 over 16 is equal to 0.25. And then I use the molar ratios for each of these. So 1 methane is equal to 2 oxygen. So 2 times the number of moles of methane, which is 0.25, is equal to 0.5. And so I did that with this as well. There's a 1-to-1 ratio, so it's 0.25, and this is the same. And so now to turn into, we have the number of moles of our 3 question marks over here. Now we can turn into grams. And that's done by using this formula, N times MR. And so that's just a manipulation of this formula that we were given. N is equal to M over MR. We just move the MR to the left by multiplying on both sides. And so N times MR is going to give us our grams. So we already have the grams for this. We were given that in the question. For grams for oxygen, we're going to find that out by multiplying 0.5, which we figured out over here, the number of moles of oxygen, times the molecular weight, which we have over here. And so 0.5 times 32 is 16. We have the grams of oxygen. Same thing with grams of carbon dioxide. We know that we have 0.25 moles of carbon dioxide, so we did 0.25 times the relative molecular weight. And so what we really got is 11 grams. And that's done as well. And then for the last one, we're being asked how many grams of water vapor do we have. And so I did the same thing. If you look, oxygen and water vapor, or water, have a 2 to 2 ratio, which is basically 1 to 1. And so if they have a 1 to 1 ratio, their number of moles is going to be the same. So we have 0.5 moles of oxygen. We also have 0.5 moles of water. And so 0.5 times the relative molecular weight, which is 18, is going to give us 9 grams. And so we have figured out each question mark here. And I hope this has been helpful. I hope this really helped, clarify the basics of stoichiometry. And this has been Basam from Bridge Gap Academy. Thank you.